Hi everyone, welcome back. Today we'll be talking about trig integrals. I'm going to split this video up into two parts because people don't like long videos, which is very fair. So we're only going to be doing the ones with sines and cosines involved in them. Essentially what we're going to need before we start is, the GOAT identity of sine squared cosine squared is 1. I'm also going to introduce like the half angle or the double angle identities, can't remember, here, which will help us later on. But essentially what we're talking about when we refer to integrals as trig integrals, it's something that looks like this. So we have sine to some power, we'll make it 4, and cosine to another power, let's make it 3. We have this integral. It's pretty horrifying, right? Like I have no idea how to solve that. Essentially what we're going to be doing here is like a U substitution on steroids. So let's just take this first step here. And I'm going to break apart that cosine cubed and move a cosine to the very end of the integral. It's really not a necessary step, but I think it's important when teaching this for the first time so we have an idea of where things are coming from. Okay, so remember with U substitution, you want a derivative present in the integral somewhere, and then you want essentially like the du to be hiding at the end, or at least somewhere else in the integrand as well. So it looks pretty nice, right? I have a sine here, and I have the derivative of sine right next to it. So, most people would say, okay, if I do a U substitution here, I can let U is equal to sine of x, and du is cosine of x dx. That's not bad at all, right? So what I can do is I can, rewrite my integral. I have U to the 4th. Cosine squared has to stay, and then I have du at the end. So the issue here is that, I'm kind of in trouble, right? I have an x term in my integrand when I'm integrating with respect to u. I also have a cosine squared, which it doesn't seem like I'm able to get rid of by writing it in terms of u, right? Well, the thing is you actually can, and this is the whole concept of trig integrals. You can use this identity up here, the Pythagorean identity, to rewrite cosine as 1 minus sine squared of x. So this right here is equal to 1 minus sine squared of x, which means, you can write it in terms of u, in fact. So I can say this is equal to the integral of u to the 4th times 1 minus u squared du. And at this point, it's really just a simple polynomial integral, u to the 4th minus u to the 6th du. And we know how to do that. This will give us a 5th sine to the 5th of x minus a 7th sine to the 7th of x plus c, and we're good to go. Okay, so this is like a very typical trig integral problem. You have sine to some power and cosine to some power, and then you simply find what you're going to make u, right? So we decided we're going to make u is equal to sine of x because we were able to pull away a cosine and leave everything else with even powers. Even powers are your friends with sine and cosine because you can sub them out using the Pythagorean identity. So I took this cube, brought one down, made it a square, turned it into a du, and I was on my merry way. Okay, so what we're going to do with this next example is a little bit more difficult, essentially because we're going to try what we just did and find that it'll fail. So let's go ahead and try a second example here. We'll do the integral of sine squared x cosine squared x. Okay, so let's repeat the process exactly. Let's do, let me pull a cosine to the back. So I have sine squared of x. I have cosine of x dx. That was a mouthful. But again, I have this du hiding out. I have a u squared sitting here. So long as I make this u is equal to sine of x and du is equal to cosine of x dx as a substitution, right? So then, let's do what we just did. This becomes u squared. I have a cosine of x sitting here, and I have a du. Now I'm actually in trouble, right? So I have no way of getting this cosine to become a sine, right? I can't really rope it up in this du because then I have weird powers going on, and I'm stuck. So this right here, this u substitution didn't work. You can try it the same way with u is equal to cosine. You can pull a sine to the back, but you'll find you have a remaining power of sine. So this would become, if you let u is equal to cosine x, du would become minus sine of x dx, and your integral would become the integral of a remaining sine x. I'd have a u squared and have a minus du. But again, I can't get rid of the sine x here. Similarly to that, I can't get rid of this cosine. So doing any sort of u substitution, as we know it, is not going to work. And so tediously, what we're going to have to do is we're going to have to use these identities here. So they're called the half angle or double angle, but really what they do is they reduce powers of trig functions, right? So I come in here with a cosine squared, and I leave with the cosine to the first power. And in terms of integration, you always want to be reducing the powers before you actually integrate. So I'm going to simply substitute this in for sine squared, this in for cosine squared, and see what happens. Okay? So we go down here and we say the integral sine squared x cosine squared x dx is equal to 1/2, and then I have 1 minus cosine of 2x, and multiplying that by 1/2, 1 plus cosine of 2x, so just subbing those identities in here, dx. It doesn't look fun, but we can FOIL it out, and in fact it's a difference of squares, so I pop out 1/4 times the integral of 1 minus cosine squared of 2x dx. And here we have a couple of options. We could substitute in sine squared of 2x, but it doesn't really matter. I'm going to keep it as this. So I have the integral of 1 dx times a fourth will give me 1/4x plus c. So that's just coming from doing this integral and adding the constant on here. And then I'm subtracting off of that 1/4 times the integral of cosine squared 2x dx. Okay, so this part's all fine. This last part, we run into a similar problem, right? There's no u substitution I can make to do anything of, example A. So I literally just have to plug in this identity again, okay? So I'm running this back here, and I get that this is equal to 1/4 x plus c minus 1/4, and then the integral is 1/2 1 plus cosine. This time it's of 4x, right? So when I input a term here, cosine of something x, I have to double that something on this inner term. So I pop out 1 plus cosine of 4x dx. And then essentially what I can do is I can actually integrate this, right? This is a constant term here. This is a single cosine. There's no squared or fourth term on it. So I have an integral I can solve. And again, with this kind of integration, that's the entire point, getting it to a point where you can actually work it out. Okay, so I hope this was a good review of trig substitution. Remember, if you have odd powers, you're in the clear. If you have even powers, you have to use some sort of not great substitution, but we know how to do both of those.